My name is Daniel Cohen, and this is my partner Harrison Fu, and we are going to show you Mo, our line tracking robot. What Mo had to do was autonomously follow a white line on a black desk on a black surface, and upon reaching the end of the line, Mo had to launch 10 pennies into a plastic container, scoring up to a maximum of 30 points. To build our robot, we were only allowed to use up to 3 servo motors, 1 light sensor, 1 ultrasonic sensor, 1 compass sensor, and 1 ball bearing. We were required to use LEGO parts and Mindstorm software.
This is a video of our robot following the line. And the robot actually tracks the edge of the line, it doesn't track the tape. So when the robot is on the tape, it turns left, and when it's on the black table surface, it turns right. And that makes the robot fishtail and just continuously follow one edge. And here the ultrasonic sensor senses something within its range, and it puts off a chemical, and that launches all the pennies. And on this tryout, we got a perfect score.
So our robot has 2 separate motors, as you can see here. This allows it to turn by either having the motors rotate in 2 separate directions, or by having one motor rotate at a different speed than the other motor. The robot also has a ball bearing in the back, which allows it to have greater mobility because the ball bearing can turn in any direction, which gives it better mobility than wheels, which can kind of constrict its movement. This is the robot's catapult right here, which launches the pennies. This is a light sensor which tracks the line. And right here is a compass sensor, which makes sure that the robot is pointing straight before it launches the pennies. And this is an ultrasonic sensor which detects the wall at the end of the line, so that it knows when to stop and launch the pennies.
The pros and cons of our robot. Some of the pros are that it gets to the end of the line very quickly, and it gets perfect or close to perfect scores when launching the pennies every time. And it's very stable, so it doesn't fall over easily. And there's a compass sensor which straightens the robot out and makes the robot point in the right direction when it's launching the pennies. And some of the cons are it has a very wide right turn, so it slows the robot down a little bit. And the catapult is not secured very well, so it tends to wobble around when the robot's turning.
So while we were building our robot, we encountered a bunch of problems. So the first problem we had was that the first catapult we built was pretty unreliable and unstable, which meant that whenever it launched, the pennies would just go all over the place. So we basically just scrapped that catapult and built a better one. Another problem we had was there was too much weight on the back, which caused the ball bearing to be unstable, and there wasn't enough weight on the front of the robot, so the front wheels didn't have enough traction to grip the table and move. So our solution to that was to just move the catapult forward, which solved both problems. And sometimes our robot wasn't always straight when launching the pennies, which caused some of the pennies to miss. So we added the compass sensor to straighten the robot when it was launching pennies.
This is our program, and right here is this ultrasonic sensor. And if there's something within 10 inches, if that statement is false, it goes down to this part of the switch. And this is a light sensor switch, and the light sensor is right here. And if the light sensor takes a reading of the amount of light, and if the value is white, which is a really bright light, then it goes here and it turns left. If the value is black, which means it's on the table, then it goes here and it turns right, so it fishtails on the edge of the line. And if this ultrasonic statement is true, which means there is an object within 10 inches of it, it will go to the top part of the switch, where there's another ultrasonic switch. And this statement is if there's something within 1 inch of it, And if that statement's true, it goes here, it stops the motors with the wheels and makes this motor C go forward, which basically makes this catapult launch. And then it stops the program. And this is a my block. If there is not something within 1 inch of this, of the ultrasonic sensor, it goes to the my block, and the my block, that's what's inside the my block. And this is the compass sensor. And if the compass sensor is within a range of 100 and 110, it goes forward, because when it's in the range of 100 and 110, it means it's pointed straight in the direction of the wooden wall. But if it's not, it goes to this my block. Inside that my block is this program. And this is another switch for the compass sensor. And it says if the compass sensor is reading a value between 0 and 90, that means it's pointed to the left of the wall, and then it turns right to face the wall. And if it's not within 0 and 90, then it goes to the bottom part of the switch. And this will mean if it's within the ranges of 110 and 360, that means it's pointed to the right of the wooden wall, and it turns left to face the wall. Some improvements for our robot is that we should have made it with slightly less wide right turns to make the turn sharper and cut off a few seconds of the time. And the catapult is not very secure, so we could have secured the catapult on the ground better.
So while we were building the robot, the project progressed pretty quickly. We finished the robot by the end of the 3rd day. I worked on the chassis of the robot, and Harrison built the catapult. We both worked on the program, and we decided ahead of time on how we were going to design the robot by drawing a rough sketch of it before building it.
And we learned how to use the light sensor and how to find readings of the light, and how to use the compass sensor and find out which direction it's pointing, and how to build a catapult using levers.
We really enjoyed this project. It was fun to try and get a robot to score as high as possible with the pennies, but at a point it was kind of frustrating to find the perfect motor powers and light values, because we had to mess around with the powers of the motor a lot to get it to have just the right turn so that it would be able to follow the line correctly and not be too slow, which took a lot of just messing around, which was frustrating. And same with the light values, we had to find light values which would make it so that it would recognize the difference between the black and white lines, which also took a lot of time. Are there any questions?